Welcome everybody to our webinar on the EBC guidelines and EBC Sink certification. Thank you very much for your interest in this important topic. I will try to keep it short as we have a lot to listen to, a lot of interesting subjects, and the presenters are most capable of presenting their topics themselves. What I can say is we have just conducted a market analysis, and we've shared a public part. Most of you should be, I guess, are aware of it. And what we found there is the importance of EBC certified biochar is of high importance, and the proportion of EBC biochar is also clearly increasing. EBC offers the producers of biochar the opportunity to prove that their product meets high quality standards, and customers are provided with a reliable and rigorous certification standard that guarantees a high quality product. So the EBC also serves as a basis for political and legislative processes. It is already mandatory to be in compliance with EBC in Switzerland, and it also has entered into EU legislations. EBC Sink will be presented in a second part. First, we will start with EBC. EBC Sink is the first method to certify biochar-based carbon sinks. And as I said in previous webinars, this for us at the moment is one of the most important arguments for biochar. To the structure, we will start with EBC, the guidelines. Nicolas Hagemann will start, then Hans-Peter Schmidt will continue, then Heike Renner will talk about the certification process. And then we'll have the possibility to have a discussion round. And in the second part, we will talk about the EBC Sink standards. So to the presenters, I'm very happy to have such prominent presenters today. Hans-Peter Schmidt probably needs the least introduction, as he is one of the most well-known personalities in the biochar world. He's founder and director of Ithaca Institute, has tremendous experience in working with biochar and projects worldwide. He has set standards for production and application of biochar several times and keeps presenting new ideas and concepts, often well before others even think of them. Heike Renner is responsible product manager, certifier, and contact person for the European Biochar Certificate at BioInspector AG. She has experience in various international organic and sustainability labels, and has accompanied EBC since the beginning in the development of independent inspection and certification services in the international sector. Nicolas Hagemann is the managing director of the German Ithaca Institute and research associate at Swiss Agroscope. He is also board member of the German Biochar Association, and he's publishing highly relevant papers for many years that offer new perspectives on the functionality of biochar. I will now hand over to Nicolas Hagemann, who will start the first presentation part. Thanks, Nicolas.
Yeah, sorry, Harald. Thank you very much for the kind introduction to both of us. But if you don't mind, I would start. And
you will start.
To Nicolas.
Sorry, I was confused there.
I tried to share my screen already, but you cannot see it.
We do, but it's not yet on full screen.
Okay. Thank you again, Harald, for the invitation to this event today. And thanks to the circumstances, we can stay at home or wherever the office is. So I would like to see all others here around and are interested in what we present here. So that will be probably next year. So it's a bit tricky to do this certificate at this presentation, because I guess that probably half of you know the EBC certification are already certified, so there might be some repetition and things, and for others it might be more new. So I try to find a good compromise. So I start with a more general introduction, and Nicolas Hagemann will then present more technical details. And in the end, I will show with some screenshots the procedure on how to start the process. So the EBC was founded already in 2011, or started to certify the first companies. That was, it seems, quite pioneering now, 10 years after, and it's even a bit worrying that it's already 10 years. And so, like 10 years, it was really something of the future, and we thought it would develop even faster as it did. But we thought that it would be very important from the beginning to set stringent standards, and more importantly, it was that no government in Europe, no authorities had heard about biochar, did know what it is, and so it was practically forbidden to use it. And that was the main reason to create these standards, so that it's a defined product, that authorities know what it is, how it is analyzed, how it is controlled, and that they could start with authorizations for the use in agriculture, in animal farming, or in other parts. And so this first certification was in 2011, but in 2013, the first authorization, which was special authorization in Switzerland, was given. And then in 2014-15, it started that more and more countries allowed the use of biochar. And either it was based on the EBC, or required the EBC, or the countries used parameters of it to decide if they authorize the use of it. So anyhow, it is, even if the name Europe is inside and it sounds something like European Union and bureaucracy, it is an industry standard. So it is not a law of the European Union, not an ordinance. It is an industry standard. However, it's legally binding in some countries. There are the guidelines and there are the standards that are developed by the Ithaca Institute. But then we have an on-site control by independent government accredited organization, which is BioInspector, we will see later. The analysis are done by accredited laboratories with specified biochar analytical methods using it. So this is really important, these two things, that these are independent accredited organizations. So today we have certified, or we have 31 biochar companies from 10 countries that are EBC certified. And we see growing interest, especially in the last six months about, which is also due to the carbon sink certificate that was introduced in 2020. And there are several new companies that started the certification process, and we estimate that we will reach more than 50 companies by the end of 2021. And also we started to certify the first US American companies for the EBC. We started as a European standard, but the demand was growing, especially from the US, to include the US American market, because they do not have any proper certification. They have the EBI analytical method, but this is not quality controlled standard. And also this is linked to the carbon sink. So the carbon sink is a global activity, and we do not want to restrict it to Europe. And that's why we opened the EBC to the other continents too. So, as already mentioned, the EBC is developed and owned by the non-for-profit research foundation Ithaca Institute. And so it's firmed under European Biochar Certificate, EBC, but you will receive emails and contacts through the Ithaca Institute, who does all the organization in the background. So the goals of the EBC is to define what biochar is, and use scientific evidence to the characterization and the analysis to ensure the safety, and it's a sustainable product, that it's conform with national and EU regulations, and that is a transparent product, so that customers know what they buy. They have, you will see in the end, they can scan biochar package units and get the analysis of the biochar anonymously on the website. So these are some of the goals, but what EBC is not is that we do not deliver any proof of how good the biochar is or how well it is suited to this or that purpose. That's really in the hand of the producers and of those who sell the product. So we can assure that it's environmentally safe, and that is according to government laws and authorizations, and it's safe to use. There are basic characteristics from the analysis that help to judge about how suitable a biochar is, but we do not deliver any recommendation that, for example, this biochar is good for electronics, or this is good for using in asphalt, or it's better suited for agriculture. You get a stamp that a given biochar can be used as animal fodder, but for example, but how good it is as animal fodder, we do not want to tell and cannot. So just to make sure, because that's something that companies are looking for, and which is very difficult, and science is not up to this for the moment, to really provide categories of properties. So we cannot deliver this. Maybe that can be done in 5 or 10 years. We have this in eyes. That's what our institute works on, what our research is about, but the EBC cannot do it. Okay. So to start what biochar really is, that's also something important where the EBC worked for the last 10 years and adapted the definition of what biochar really is. And it's not so easy to really define it. So it changed, and it's quite interesting to see the changes over the last 10 years. So biochar is a porous carbonaceous material that is produced by pyrolysis of plant biomasses. This is important. That's what it's made of. So the first is what it's like physically or chemically. Then the third parameter is what is it used for, and it is applied in such a way that the contained carbon remains stored as a long-term carbon sink. And that means biochar is not charcoal that can be burned. So the definition of its use is important here. Or it replaces fossil carbon in industrial manufacturing. So it is not made to be burned for energy generation. So you cannot distinguish chemically biochar from charcoal, but you can distinguish it related to how it is used. So we can see also that biochar is black, and sometimes all that looks black is defined as biochar, which is really the hard business to see why we define it in that way. So you have here 3 different biochars, and they look all 3 very different. So the one you can see here in red has a carbon content of 18% and has a lot of phosphorus, while the second one has 48% of carbon and more than 10 times less of phosphorus. And the third one has 100 times less of phosphorus, but 80% of carbon. And still, all these 3 materials are considered as a biochar. They're made from different feedstock, in this case wood, paper sludge, or sewage sludge. And so we have to find this definition that englobes these differences of the material and still makes clear what it is and that it is safe to use as biochar. And for this reason, we created these guidelines for biochar production. It is now something that has about 50 pages. It grew over the years, and still we try to keep it simple. We try to not overload it with details, but we also try to have explications and explanations on why we decide in this or that way. And so we try to make it something readable for people that are interested in biochar. And from here on, my colleague and friend Nicolas Hagemann will take over.
Yes, thank you very much. So it's my pleasure now to introduce the EBC guidelines for biochar production to you. As already mentioned, the document is already growing and hopefully developing, not growing, developing for 10 years now. And first of all, there is not the single EBC standard or certification. We have 4 different application classes, and this is the EBC Agro, the EBC Agro Organic, the EBC Feed, and the EBC Material. The latter is the youngest application class, which is meant to promote the use of biochar beyond agriculture by having less strict thresholds or limit values to allow the further use of recycling materials in biochar. Still today, agro and feed are the most important parts for us, but we will look at this in a second. So first, what is these were the classes, but what are the pillars on what the EBC is founded? And so it starts already with the provision of the feedstock. So the first criteria is the sustainable provision and the production of the biomass, so our biochar feedstock, the energy efficient and low emission pyrolysis technique, then the actual biochar quality based on a correct biochar sampling and analysis to ensure overall low levels of contaminants in the biochar. So with that, we'd like to ensure the low hazard of use and application of the biochar. And as Hans-Peter Schmidt just said, is the goal of the EBC is to show that we have a safe product, not more, but also not less. So everything here is under a do no harm principle, and this is what is going throughout the EBC and also throughout this part of the presentation. So you'll see now we also, to make it easier for you if you want to study the EBC in more, the guidelines in more details, we still refer here to the original chapters of the EBC. And so we start here with the biomass feedstock. And here this is very closely linked to the definition of the biochar. We only permit the use of plant biomasses that are allowed to be used for EBC certified biochar, irrespective of the class. And what a plant biomass is for us is defined in the positive list of permissible biomasses for the production of biochar. This is a separate document, an annex to the actual EBC guidelines. And you don't need to read this. It's just to introduce you a little bit to the structure and the way we create and also maintain this list. Is we define various origins of the biomass. Of course, agriculture should be an important one, as it creates a lot of organic secondary products that could be used. Actually, at the moment, forestry and wood processing is the most important source for biomasses. And then we clearly define certain feedstocks. Each feedstock has an own ID, and then we define for which class you're allowed to use a certain type of feedstock. So you can easily see here there are a few feedstocks that you can use for all 4 classes, and even including the EBC feed. We do have some special requirements for certain feedstocks, and these are listed here to the right in the comments. So it's a very comprehensive list. This list is also it's a living list. It may be amended, but we'll get later to this. So this is everything. As the whole EBC, we constantly working on this to further improve this list. As mentioned before, the intention of the introduction of the class EBC material was to further open the possible feedstocks to be used for biochar production to enable the creation of carbon sinks. And so let's say for EBC material, we have the most liberal policy with regard to feedstocks, and especially with regard to impurities such as plastic or rubber that may be part of that feedstock. Still, let's say terms and conditions apply. If we have high amounts of these impurities in the feedstock, this needs to be declared to the customer who will be buying this biochar, and also needs a written approval of the EBC. But the whole topic of having plastics in biochar feedstock is very important to us. We are working on this to further understand which kind of plastics in which quantities do have what kind of impact on biochar quality. So there will be some development in the next year. And as I already indicated, everyone or each company is free to suggest new feedstock that are not part of the current feedstock list, or even may suggest new application classes. And the procedure that we agreed on with EBI is that you who have this intention or this idea should address EBI and discuss these ideas first with them, and then these ideas are communicated to us through EBI. Then that means the Ithaka Institute, will do the risk assessment and will draft the new certification guidelines or draft the amendment to the feedstock positive list. And we will then discuss this draft amendment or draft standard again with EBI and further refine it to the needs of the praxis. And once we agreed on a standard, this in the end needs to be approved by the scientific board of the European Biochar Certificate, which is comprised of scientists from Germany, Italy, and Switzerland at the moment. Now, having produced a biochar from a certain feedstock, we now want to analyze it. And prior to analysis, there is the sampling. And this is, for us, a very important topic and has been a very also interesting topic in the previous discussions that we have with the community through EBI. And but it is really a critical point because biochar is, to some extent, a very special material. And just to I don't want to bore you with the details of sampling, but I just would like to highlight that we did that ourselves with our colleagues from Agroscope, a Swiss governmental research institution, and we have been shoveling almost a ton of biochar, one batch of the daily production, shoveling it into 125 subsamples, and doing a lot of analyses of these various different subsamples to learn that it's really important to have representative sampling. Because if you just do the grab sampling, of course, for carbon content, this is no problem. But with regard to PAHs, so polycyclic aromatic hydrocarbons, which are, say, the most one of the most important aspects of biochar safety, this is not viable. We need to have a proper. We do have to have a proper sampling. Up to now, this or since this year, this has to be done by a person who is accredited to do that and has been doing a training. So far, this has been only be done through Q-Inspector, but now in cooperation with Eurofins, we can open this, as Eurofins will offer a sampling training for biochar according to the EBC guideline. This will be an event with two parts. The first one will be a virtual event in later this month, and we are very happy that we can announce this year. And this will enable biochar producers to train one of their staff in this training, and will then be able again to take their samples themselves, which will facilitate having multiple biochar production batch throughout the year. So having done the sampling and sending the biochar to an accredited lab, we will then look into the biochar properties. And of course, the most important one, or the one that most people are aware of course, the biochar carbon content that must be declared. It's not like that a high biochar carbon content is something that we specifically aim for, but of course the biochar carbon content of a biochar must be in accordance with the feedstock being used. We further look into the H2C molar ratio. This must be lower than 0.7, and because this gives us a lot of information on the process, on the intensity of the pyrolysis. We need to have declared the biochar nutrient content, and of course, most importantly, we need to look at a lot of stuff that we don't want to have in biochar, which we need to minimize, and that is on the one hand, the heavy metals, which are simply a function of the feedstock that you're using, because because most of them simply accumulate in the solid product of pyrolysis. So we have 3 different levels of heavy metal limit values, one for EBC material, one for EBC agro, and one for EBC agro organic and feed. They are basically the same. So you see, we have the least strict regulations for the EBC material. They mainly originate from with regard to labor safety. So simply that it's safe to work with the biochar, while for agro-organic and EBC agro, those limit values are defined in a way to be conform with fertilizer regulations. Other properties that we look at is the pH, the bulk density, water content. We also recommend to measure the water holding capacity, but is not mandatory. Up to now, we also look at the specific surface area based on gas absorption. And then, of course, it's very important to look at the organic contaminants, that is the polycyclic aromatic hydrocarbons, because they are simply a function of the pyrolysis process. And thus, if we have something happening in the pyrolysis process, some, let's say, bad process control, anytime PAH may form on biochar. This is so important to be controlled. For further, more nasty organic contaminants like dioxins and furans, so PCB and PCBDF, there are certain specific circumstances when they can form. So if you're not producing feed biochar, this analysis usually only has to be done only when you start to be EBC certified. It's not necessary to do this rather expensive analysis every year. As already mentioned several times, special emphasis on the polycyclic aromatic hydrocarbons. We have here today very low limit values. When the EBC started, we had the threshold of 12 milligrams. It was the EBC standard and the EBC premium, which we had to change into the EBC agro-organic and EBC agro due to the upcoming EU fertilizer directives, and also to be compliant with, for example, with the Swiss directive. And so they have these rather strict limit values, but in the end they are good because we have our do no harm principle, and we see that the technology is there to produce these biochars. For EBC material, we have a higher limit value, as already mentioned. Also for the heavy metals, this is defined to be able to work with it without specific protective measures to be taken. For the analytical methods, we clearly define which methods to be used, and also this is not something that just dropped from heaven. This was a very huge project within a coordinated EU project, the EU Cost Action TD1107, where we conducted an interlaboratory comparison. So it means several biochars, the ones that Hans-Peter showed pictures in the beginning, they were sent to many laboratories across Europe and have been analyzed with different technologies and methods. And from this, we could distill which are the most suitable analytical measures to quantify biochar property. And in addition to clearly defining the analytical methods, we also only use accredited labs, and that's at the moment there are 3 of them. That is the Eurofins. We also put Eurofins Umwelt Ost specifically. Eurofins is a large group. Only 1 lab of them is accredited to do the biochar analysis. We have the Ruhr lab, and we have Münster Analytical Solutions now for also the 3rd laboratory, for now focusing only on the organic analysis. What they have in common is that they participate annually in a ring trial, which, and so similar to what we did to define the methods, but here it's simply to test the laboratories, and they have to prove on an anonymously sent sample that they can do these analysis correctly. And so this is repeated every year. They have to pass this test to be still an accredited laboratory. So this was all things on the product, but also the certification is more than just looking at the analysis. It's also about looking at the whole technology and applying do no harm principle here. You need a state-of-the-art pyrolysis unit that is energy efficient and does not pollute the air. And so that means the syngas needs to be treated properly, and request that the excess heat of pyrolysis is used in some beneficial way. For the certification, the biochar production plant needs to be inspected every year, and at least during the inspection, we need to do the sampling and end a certain production batch of the biochar. But when during the year the biochar producer changes the pyrolysis temperature by more than 20%, or he makes a change in the type of biomass or in the blend of biomass used by more than 20%, then a new batch has to be started as well. And that means the new batch has to be announced on the website. We'll get back to that later, and a new sample has to be taken. And so this is a very important aspect that I'd like to stress here, that it's not always 1 year is one batch. It's you need to have a constant conditions of producing it. Beyond that, of course, during inspections, we look at the work, labor safety, and health aspects of the pyrolysis plants. Biochar sampling is what we discuss in detail. You also producer needs to take samples and store them for a certain amount of time. This is something that also led to quite a number of discussions. But again, here this is we as the certifying body, we don't need these samples, but we request the biochar producers to have them simply for their security. If there's any problems with biochar coming up and people say, hey, you were selling pH polluted biochar, you have these samples, can use them for additional analysis to prove that your biochar was clean. And so I know that there's been a lot of discussions, but we are still very convinced that this is a very necessary aspect of the certification. And then, of course, we have certain guidelines on how to use our label that you can see here, and how it is allowed to be used on the product. Yes, so much on the details of how the actual certification is done. Yeah, so we have this. It's actually performed by Q-Inspect, and I'm very happy to have Heike Renner with us, who will give some more details on this. And yes, so far on the annual inspection.
Thank you, Nico. I see you have adopted the Swiss punctuality.
I will. Yeah, we are a bit over. Yeah, okay. Do it like this. It's good.
Perfect.
Great.
So hello, everybody. Do you see my screen?
Yes.
Somehow I lost
Perfectly.
The full screen. Do you see my full screen?
Yes. Yes.
Okay, because I need to switch over to my other screen here. So apologize if I think I may switch off my camera, that I can concentrate here on my presentation. So thanks a lot, Nicolas. Thanks a lot, Hans-Peter, and thanks a lot, Harald, for the invitation. My name is Heike Renner. I'm responsible in between Bioinspector, Q-Inspector for the label program of EBC. So since the beginning, together with Hans-Peter Schmidt, we developed this inspection and certification process. So nearly, I think, over 8 years now, we are in charge of inspection of and certification for the program. So, so I would like to introduce and tell you, give you an overview about our company, portrait of BioInspector, Q-Inspector, and also the EBC inspection and certification process. First of all, I have a few slides about our company with milestones, indication, organization chart, and our team. I go quickly through that, as everybody will get this presentation afterwards. You can still come back and look at those figures. So it's quite a lot. So BioInspector established already in 1991, and so we have over 20 years now experience in inspection and certification process, are market leader in Switzerland for organic label programs, but have a lot of partnerships and also subsidies and sister companies. So we are developing also internationally, and also the label EBC is located in the international department. Yeah, so this is an overview. I don't want to get too much into details here. And also, where are our offices and subsidiaries? You have here an overview. So EBC is located, the label program in Switzerland, but we can go also global with that label. And also we are working, we have a net of inspectors who are working for us. So yeah, we can arrange inspection and certifications worldwide. Also here the indicators, more or less. I also don't want to emphasize here a lot. Yeah, you can go afterwards to our link and read everything, and also our about the figures and the annual reports, which are also stored there. So from the organization chart, the EBC is located in our international department. It's here. It's one of 5 departments we have. So our head of department is Fasani Madipur, and I'm as the PM are also located here. Here's are the people from the management board, our CEO Willi Steiner, and all the head of the departments. So Fasani we have over here, who's in charge also for EBC label program. Then our international team, or for EBC, it's mostly me here, and my colleague in the back office is Stefanie Schlumpf for all the administrational work. Our auditor, he's the man for the on-site inspection. It's Philip Seitz. He's also a very experienced auditor. And he's also now doing audits, yeah, since the beginning. So here you have an overview about all of our services in between the international department. So EBC is one of a lot different kind of organic and sustainable label programs. And you can also go to this link and you get more information there. So I would like to emphasize now more on the EBC inspection and certification process. Give you an overview why certification is recommended, and I want to lead you a little bit through the steps of certification, how to become certified at the end and published on our platform. Yes. So why EBC certification? I think it's important for a label program that you have a independent inspection certification, which takes place to build up consumer trust and also to contribute to a fair competition in between the whole market. So all in all, a certification contributes to a sustainable market development. And after you are certified, you can use the EBC certification logo and our Q Inspector certification mark. Why Q Inspector? I just our company is bioinspector, but we used Q Inspector for label programs which are not in the scope of organic farming. Yeah, because the bio means organic, means that it's in the scope of organic regulation, and biochar is not in the scope of this regulation. That's why we use in the certification Q Inspector. We are the same company. It's only that this program is located with Q Inspector, and we at the end we issue a Q Inspector certificate. We have a fact sheet which you find on our website, for clients who are interested in to get EBC certified. And also we have possibilities for label programs to get a blog entry, which we have here. And so everybody can get information there. So our service as an accredited inspection and certification body are all independent. We are not the label itself. The only thing which I reflect always to the label is, okay, how can we inspect the requirements? Do we need to adapt anything in the standard? And there I give feedback. Then you can trust that it's a credible program. Our services are encouraging, so we also focus on what requirements are met, and at the end what is missing, what need to be corrected before we can certify an operation. Our auditors and all in all, we deal our clients respectful, and our services are correct, which means we have a 4 eyes principle. So the auditor is doing the audit and comes up with findings during the audit, and the certifier does review these findings, and before a certificate is issued, that everything is checked by 2 different people. And also the operators at the end, they have the right to appeal. So if an operator thinks that the decision was not right, he has always the possibility to appeal, and then a third party will review the whole process again and checks the documents again and everything. So inspection and certification, 2 parts. An inspection is on site and is conducted with a checklist and summarize at the end open deviations, non-conformities, which are given time frame that those can be resolved. And that certification at the end is the 4 eyes check, the review, which will be done in the office of all the documents, and everything which is required. So here I just listed the steps towards a successful certification. So it starts with the registration. It's new now that everybody needs to register at EBC website and enters all required data there. And after that, you may request with us an offer for registration. And after a prepayment is done, we give this order for an audit to our auditor, and he will do an appointment with you and checks on site with the checklist all the requirements. Our audits are done via a software tool. It's called eCert. I will give you a quick view into that later in this presentation. The audit will end with an audit report where all the non-conformities or deviations are listed, with maybe deadlines to resolve that. Important non-conformities, or we call it major non-conformities or B sanctions, need to be closed and before a certification process can be closed. So after the audit, there will be a follow-up. We call it deadline management. So all open non-conformities need to be closed. So operators will submit us their written corrective measures. And then at the end, the certification, the review will be done of all the handed in documents, and the certificate will be issued with the ID number of the biochar, EBC biochar batch. And you get at the end the publication, which will be online on our EC Cert portal. So this is our eCert IT software. This is what it looks like when the auditor goes through the audit. So every checkpoint needs to be checked, and if everything is okay, he will mark it here with yes. He will comment every checkpoint, and you see here on the left the green light here is that it's correct. If it would be not correct, there would be a deviation. So the auditor will report exactly this finding, and this will be at the end listed and summarized in the EBC audit report. So after the sanction management or deadline management is closed, after the submission of corrective measures, you will, if you don't submit the corrective measures in between this time frame, you will get a reminder, and we check if we might come up with a new date for closing date, or we see what the problem is. Then the order for certification will be forwarded to the certifier. So you can see it above here in the workflow. Then it comes to certification. The certification is the 4 eyes review, the evaluation of all audit documents and written evidence, and yes, at the end we issue the certificate. So this decision will be also communicated to you in a certification decision letter. And this is what the EBC certificate looks like then at the end. The blue color here is our program for Q inspectors, or that's a Q inspector certificate. And the certificate comes with an up-to-date product list where the biochar batch is listed with the actual number and registration, which you registered on the EBC webpage. At the end, we come up with the publication on EC Cert. You can, the certified operators of you, find yourself there with the address where you're located and with the certificate. So everybody, your clients, can get an overview for what batches you are certified and what is the actual EBC class you are certified for. Well, and after certification, you are able to use the certification marks. Also we report that back to EBC. And that's it. So a successful certification means to have a clear and transparent structure in the audit and certification steps, to have a transparent communication with the operator. We have a simplified audit and certification process with these IT solutions, and you have an easy access, and your client have an easy access to the certificate and product lists. And yes, to our service also, we are available for you and support you and are there for open questions. So I think we summarize your questions at the end. These are my contact details, and so thank you very much for now, and looking forward to our discussions and further questions later on. So thanks a lot.
Thanks a lot, Heike, for guiding us through this process, and Hans-Peter Schmidt and Nico Hagemann also. We agreed on having a first discussion.
Right. Sorry to interrupt you. If you wouldn't mind to give me another 4 minutes, I would like to add just a few more information on the how to do, and then you could start the discussion if you wouldn't mind.
Of course.
Okay, thank you. So just to mention also that this it looks quite complicated, all this on the first view, but we try to make it simpler every year. So we invested a lot into a new IT structure, and that should help you to go through this process and to accompany you also with consulting, so that it becomes not too big burden. So there are some costs implied. One is the actual control that Heike Renner showed you for bioinspector or co-inspector, which is about 1,500 to 2,000 euro, which depends also on the distance to travel. So for the American companies, for the moment, this is more expensive because it's longer travel time. Then you have about 700 euro for the standard EBC analysis that goes to the accredited laboratory. If more organic contaminant, like for animal feed, has to be done, it becomes a bit more expensive. In the beginning, we started to provide all the service for free to allow the development of the standard, but the bigger it becomes, the more cost we also have, and we need to cover these costs. So we require a EBC label fee from 2021, which is between 300 and 450 euro, and an inscription fee, and for the first audit, where we create the special audit booklet for the company. And the carbon sink certification is 1 euro per ton of CO2 equivalent. You will see what that means in the second part. And usually the carbon sink certification fee is taken over by the carbon sink traders, but you will see this also later. So just that you have an idea what costs are implied here. And we certified different types of companies. This one is, and the major part is biochar producers. But in order to use the label also for products that contain certified biochar, we also have to certify and control the manufacturer of biochar-based products and also traders of biochar. We have the carbon sink traders accreditation, and we do pyrolysis type certification. And just very shortly, how you would start if you are not certified yet. You go on the EBC website, european-biochar.org, and then you can register your company here. You have the explications, and the actual company registration is there. So you put in all your data, and you agree on if you want to become certified or just go register for your company in the EBC website, which you can also do without getting certified. But if you want to be certified, you allow us to share the data with bioinspector, who will send you then the offer for the controlling and certification, and you will get contacted by Ithaca for the first audit to start the whole process. And then you are in the back end, you can manage all your company data, your pyrolysis units, you register your batches, you register your samples, you get sheets how to send the samples to the laboratory, and all this is in communication with the laboratory directly, who send back the results to us and to you and to bioinspector. And also the carbon sinks accounting is done via this web interface, and you can also manage several companies if you are like a holding. So you have to register every new production batch, which you can only do when you finish your batch. When you finish the batch, then you provide the actual amount of biochar that was produced, and so the creation of a new batch sends the information to bioinspector that there's something new to control, and it sends the information for new carbon sink certification and for the sampling. So this is more automized than before. And once you have your batch certified, you can download the QR code to be printed on your labels, and they link the analytical data of the biochar batch like this in an anonymous way on the website, and you also get a PDF. So if a client buys the biochar, he can get this most important analytical data without knowing who produced the char. So for example, you sell the biochar to a manufacturer who does a biochar-based product out of it, or to a trader, and you do not want them to know where it comes from. That's not necessary, because we take care of that you can get all the informations in an anonymous way, and also the certification class. So that's the short edit, Harald. Thank you for the patience and for this first part, and we're happy to answer some questions and leave enough time to do this presentation on the carbon sink also. Thank you.
Well, thank you. You might have clarified a couple of questions that would have come up now. Now, to everybody, if you have questions, you can either post them in the chat or raise your hand. There is a hand symbol next to the microphone, camera symbols, and the chat, and then we can ask you to unmute yourself, and you can ask your question directly. There's a first question already from Hannes Jünginger, which is, what's the typical time needed between initial application for EBC to certificate issuance?
Yeah, we count more or less 6 to 8 weeks. In urgent cases, it can be quicker. Sometimes with travel restriction like now, we try to accommodate it. Bioinspector also does some video audits now. So it should be less than 2 months.
So that should be quite encouraging if you want to be able to produce EBC certified biochar and sell it as such. It's relatively little time for you to have the certification.
May I add something?
Of course.
When it comes to the timeline, it really depends on the completeness of all requirements and evidence papers, and so in case of there is a deviation recorded during inspection, during audit, the auditor will specify a deadline handing in the corrective measures. And it really depends on that, how fast operators are to come up with these evidence papers. Normally they get 1 month or 4 weeks of time, and mostly it's missing analysis result, for example. Then it takes, for example, a month. And we do 2 reminders where operators get another 2 weeks. Yeah, so we have a period of 2 months only for handing in documents if the operator does not have the complete set of evidence and requirements ready in time of on-site inspection. So that would delay the timeline, but it's up to the operator. And before an audit, we will send a preparation list also to everybody that the operators are prepared for their on-site inspection, that we can secure an effective audit and they come up with a good outcome very quick. So, thanks.
Yeah, maybe I can add something that like in Sweden, we have more and more companies in Sweden, and there's a company, consulting company specialized in helping the producers throughout the whole certification process. So that accelerates everything because all is completed then, and they get the right information. We'll also see is that pyrolysis technology producers do the first certification for their client to help them. So there are also possibilities to professionalize the whole process.
Thank you. I have another question from Daniel Krei. If you want to turn on your video, or should I read the question out? So he thanks you for the interesting update on EBC. As biochar needs to grow to gigaton level in this decade, the need for characterization and qualification will also exponentially increase to many thousands or even millions of samples per year. Is bioinspector and Q-inspector aware of this and prepared? It's an interesting question.
I mean, I show you that we are working with an IT system, and I'm also in charge for training of auditors and certifiers. So, yeah, I mean, we can be very quick to also train more inspectors. At the moment, we have 31 operators certified, but we can react quite quickly in our international net to also train more inspectors. So, yeah, I think we are prepared to get more clients.
Yeah, and you see this is like it's also we're happy to work with bioinspector for 15 years now, because we created another standard before this, also with Heike Renner for biodiversity in vineyards, and they do the inspection for most of the organic farmers in Switzerland and in other countries. And if this is like 15 to 20% of farming is organic, this is all certified. So it's same system. I think it's prepared. Yes, make the gigatons, and we take care for the rest.
Great. So also in our market analysis, you have seen that growth is exponential. So we're happy to see that. Any other questions? I do not see raised hands, and I think it's because there are none.
There was one question from the very beginning. There was about certification in the US. Whether if bioinspector has or has the capability of doing the inspection or the audit in the US.
Mm-hmm. Thanks. I haven't seen it.
Yeah, Heike, I answer for you because you are still muted. So yes, we started the certification for the first two biochar producers in the US, and one carbon sink certification is already done last year. So yes, we go for that.
I think Marcel wants 2 gigatons, Marcel Huber. But I do not see. Yes, please.
Yeah, thanks for the webinar and for the discussion. And yes, of course, after the first comes the second. There's a lot to do, but as I recently talked to Hansjörg, the gigaton is quite a challenge. So if you make it visual, it's a lot. So, but it's one step after the other. I have two questions, and yesterday Dominik Dunst asked me, and I didn't have the chance to check myself, but he said something about two analytic methods in the new EBC form for the polyaromatic hydrocarbons. I'm not sure. For me, it would have been new. So there's only one, or is it? Maybe you can comment on that. I tried to look in parallel, but I couldn't. I'm not so quickly in the guideline.
It's no new methods. It's just method development is going on, and there are different standards between the DIN and the ISO, and we try to keep updated and try to include all the methods, because we would also like other laboratories to participate and to help here and to provide all the, if possible, all in ISO methods. But is nothing fundamentally new. It's only that there is a new numbering. There is nothing new.
But in fact, he's right. So there are two standards now defined which allow proper polyaromatic hydrocarbon analysis. Not the DIN only. It's also ISO. Yeah. Not totally different, of course, but it is different. But it's, as you said, okay. The second is how do you see this tech issue? I have found this PCB remark already in the new regulation that all these toxic substances go not under a lump sum of limits, but under this TEQ understanding. What do you see in the outlook? I mean, that goes for dioxins, that goes for all toxic substances as I know it, very on the surface, but how do you see this development in the next versions? Will that change from the lump sum to a tech?
Yeah, there's something that's a bit worrying, troublesome. It's the new EU regulation. As you may know, that there were some people implied in their doing that had not full understanding of the topic, and so they require now PCB and dioxin analysis for all biochars, so which we only require for feed quality. If that becomes the rule, then all biochar would have to be analyzed according to these new regulations. So, and in that case, we just follow their rule. I mean, these windmills are too big for us to fight. So we just let them turn and take the wind to go forward.
Yes, thanks a lot. I see there's another hand raised by Dominic Dunst. Do you want to unmute yourself?
Yeah, thanks. My question was already answered, so thanks.
Sorry, Dominic, I didn't see that you.
Yeah, it was the same question like yours, Marcel.
Yeah.
So maybe Harald, if we could, because time's running,
Yes.
if you want, we introduce the carbon sink, and if there's some time left, I guess there are more questions on that.
Exactly, please.
So I will share. Nicholas and I we will do it again together. I share the screen. So. You see it?
Yes.
Good. Okay, so I try to do it quickly, and I promise if interest is we do a whole webinar on carbon sink to go into the details and into some physics that we will skip here now. The very important point that we want to raise in the beginning is that there is a real fundamental difference between the carbon sink and what it's usually used as carbon credits or CO2 reduction. In fact, and that would need the next webinar, carbon sinks and CO2 emissions is two very different things. CO2 in the atmosphere is dispersing and will stay, parts of it will stay for millions of years, while the carbon sink is carbon that is stored and that may turn back to the atmosphere at any time. So what we do at the EBC is really to certify the carbon that you can touch with your hands, and that is really a sink. So that's a physical sink. It's something that's on Earth, in the Earth, while carbon credits are given since the Kyoto Protocol for the reduction of CO2 emissions, which is a very important thing. Which is clear, and you can reduce, for example, if Syncraft makes electricity and heat from wood, they reduce fossil fuels because you do not need fossil fuels to make this same energy, and so in the Kyoto Protocol that's valid. It's could be regarded as an emission reduction, but that has nothing to do with carbon sink. Carbon sink is only the carbon that you can touch, the biochar that you can shovel and that you can bring into the soil or into a material. So we need to keep this apart, and there are efforts from different organizations that see bigger dollars in including everything and promising everything. For example, if biochar is used to reduce to reduce N2O emissions, then they want to accredit this also, and then they come up that 1 ton of biochar is equivalent to 5 tons of CO2 or something, which is very unphysical and worrying because it may destroy the whole system and the confidence in the system. What we try is only to credit what really is in the sink and what stays in the sink for at least 100 years. And we need to see the whole process. So it's not that only the biochar that comes out of a machine and then we calculate the carbon and transform it into CO2 and that's the sink. No, we have really to look at the whole process from the biomass, because it's the biomass that extracts the CO2 from the atmosphere. And what we do with the pyrolysis is to transform the carbon that was extracted from the atmosphere into a more stable form. And the climate action is the extraction of the CO2 from the atmosphere by plants, the transformation of the carbon in pyrolysis, and the application to a long-term matrix like in soil. So these are the three essential steps that are interlinked and that we have to look as one picture and not only part of it. So clear-cutting a forest and transforming it into biochar is certainly not a climate positive action. And so we do these calculations, and I will not go into these details. So what in fact happens with the carbon when you do, for example, clear cutting? How much of the CO2 is going to the atmosphere? How much comes back from the atmosphere after how many years? And what is extracted to the regrowth of the forest? And then you make an overall balance. And there is one balance, which is the carbon, that is the blue line, which shows that after 74 years of regrowth of the forest, so it takes 74 years that the system is carbon neutral. That means as much carbon was taken up by the new grown forest as was emitted by burning it. So this is biomass, but this is not climate neutral. This is even not carbon neutral. Only becomes after 74 years, which is by the end of the century. So take care when you burn wood. But if you regard the global warming effect, this is even worse, because the CO2 that was emitted to the atmosphere and is only partly coming down to Earth. So there's always some part of the CO2 that has the greenhouse effect, and this greenhouse effect is more relevant than the effect of extracting CO2 from the regrown forest. So this blue line shows the climate effect of a clear-cut forest and regrowth. And you see the climate effect, even after 250 years, is negative. But it becomes positive, as you can see the blue line here, when you have a system where you only pyrolyze the annual regrowth of the forest. So you do not clear cutting, but you take only the regrowth of the forest, you pyrolyze it, and you can see that from the first year you get the climate positive effect. So that's really what we have to look at, and how do we get the biomass? And only when this is proven, we can start certifying carbon sinks. So this is Finland. The first image was in the US, but still, it's clear cutting is the main way how to gain wood in Scandinavia, and this is they're considered advanced countries. So, not going too much into this detail, it's just to alert here that not all biomass is same, and that we start the assessment of the carbon sink potential at the biomass production site, that this is sustainable. And so we have different categories of biomass: agricultural biomass or waste biomass, wood wastes, biogenic residues, and we regard all these biomass differently and make sure that the climate balance of the feedstock provision is included in the carbon balance. And we account for all the pyrolytic treatment. So we have transport to the site, we have chipping, drying, the pyrolyzer may need electricity, or it may need some fossil fuel for preheating. It has emissions that we have to account for, and then it is transported to the product transformation that makes biochar-based products. So emissions of pyrolysis are very low, and usually if that is only CO2, that could be considered as climate neutral if the biomass feedstock was neutral, because then burning is the same as decomposition in the forest. However, if you have other greenhouse gas emissions in your pyrolysis, and especially methane, that has a higher global warming impact than CO2, so the climate balance may become more critic and even negative, depending on the technology that is used. So we really need methane emission measurements for the pyrolysis plant to calculate the carbon sink potential of the biochar. So we need to account for all greenhouse gas emissions. So this is during pyrolysis process, but also during storage of the biomass. And then the interesting thing is what happens with this biochar, because as long as the biochar is just packed into a container or into a big bag, it could easily become charcoal and be used for barbecue or for other purposes. It can still be burned. However, once the biochar is applied to soil or to compost or to liquid manure or used as animal feed, it cannot burn anymore. It is in a matrix that preserves the biochar, and then you only have biological degradation. But it's known that biological degradation of biochar is very, very slow. And there are different publications. I mean, we cannot see too far in the future, so we try to keep how much is left after 100 years. We do it very conservatively. Using the most conservative study, came up with an annual decrease of the carbon sink, so the carbon that's lost when biochar is applied to soil, like 0.3% per year, which is very high. The reality is lower, but that's something that we can really guarantee. We do not want to sell carbon sinks that maybe after 50 years they will tell us what did they think. There's no carbon left in the system anymore. So we have to make sure that we are on the positive side. That's why this 0.3%. However, we calculated mean residence times from natural pyrogenic carbon, so that's biochar that's produced during forest or prairie fires. And this is in preparation for publication now. And here we can guarantee mean residence times that are between 1,500 very conservatively up to nearly 15,000 years. So in nature, this biochar stays for so long time in the terrestrial system. It may not stay exactly in the same field as you applied it, but through rain and erosion and dissolving very small particles, the biochar will end in sediments where it's preserved for more than 20,000 years very stably. And that's also the reason that can come up with these calculations that provide data that are much higher than some laboratory data that you have. Okay, so how do we do the actual certification process? So we have these kind of data sheets. The producer has to provide several data, and this is counter-checked by bioinspector controlling. And one major part is the pyrolysis unit. And here we aspire for pyrolysis type certification. So once a pyrolysis machine is built more than 3 times and at clients, the company can acquire the type certification, and then we get the major data like methane emissions and particulate matter and energy efficiency, things like that we get directly from the type certification, which is automatically then used here. And in the end, you get the carbon sink data sheet that's like the certificate. And that lists all the emissions that were caused by the production of the biomass, of the pyrolysis, how much methane that is given extra. And then you get the actual value of the carbon that can be considered as a sink. You also get the climate neutral energy, and that is produced with the machine because all the emissions are compensated by the biochar. And then you get the total greenhouse gas emissions per ton of biochar that were caused. And you get the CO2 equivalent content of the ton of biochar, and the difference is what you can provide to your carbon sink trader as the carbon sink potential. And maybe, Nicolas, if you would like to continue from here so that I do not talk too long to explain the carbon sink value, or otherwise I can also finish here.
So based on all these values, we then start from the carbon content of the. So we're going back to the physical product, to the biochar, and look at its biochar carbon content. And from this, we calculate the carbon sink potential as we transfer all this data that Hans-Peter just showed you on the certain batch. So we calculate how much emissions are there during the production of this batch, and then transform this on a value per ton of biochar. And with that, we can calculate, okay, how much carbon is emitted and as a fixed ratio to the amount of biochar produced. And so with that, we can subtract the amount of emitted carbon or emitted carbon equivalents from the amount of carbon that is stored. And this is what you see here now in this calculation. We start with here, as an example, an average wood biochar with 75% carbon content, and we then have to subtract 5% of carbon content in that biochar for the biomass production. We have to subtract another percentage for the energy that is consumed or emissions produced by the pyrolysis unit, and then we additionally subtract a margin of safety, and that is what you can see here, additional 10% of the total subtractions of the total carbon expenditures, as we also use in the standard, to account for everything that is not covered by the two values above. So that is all small operational things of people who are familiar with carbon budgets. That's what you call the scope 3 emissions. That is everything from traveling of your employees to keep your business running, or also some minor emissions from the biochar storage and so on and so forth. And so with that, we get to this value of here 66.5% of the C-sink potential of this amount of biochar. And from there, you can exactly declare, okay, this big bag has that X amount of biochar, and with this Y amount of carbon sink potential. And then the biochar starts traveling, and then this carbon sink potential can only be effective once it is applied, for example, to soil or any other thing that is on the list that has been shown. Yeah, and so we can really link the physical product to the carbon sink potential that can be created, and just very figurative here, the 0.19 tons of carbon sink within one of these big bags that you can see here, and of that. They, of course, each of them has to be tracked. First of all, they need to be they are the registered carbon sink. That's what they become once they are applied, for example, to soil or to qualified feed products. And this is where also the service of the Ithaca Institute or of EBC stops, at least with regard to the physical product, because to have this tracking that is necessary to really turn the carbon sink potential into the actual carbon sink cannot be done by us, because we stop our certification at what we call the factory gate. So after the pyrolytic treatment, and once the biochar is in the big bag, this is what is covered by the carbon sink potential, and this is with that, as it is a potential, this is the upper limit of the amount of carbon sink that can be produced. And from there, if you're the owner of the pyrolysis unit, you're free to sell this carbon sink potential to an accredited carbon sink trader, and who will then take care to track the physical biochar through any kind of product transformation in EBC certified biochar product producers up to the ultimate carbon sink storage. And so here there is and we aim to have an overarching system that will be established by the EBC, but also be used by the carbon sink traders, so independent companies, that we have all the data on the sink or the creation of the sink in one system. Still, we will have the factory gate as this boundary of EBC sink potential issued by EBC, and the tracking by the carbon sink traders. So the carbon sink traders have a very important role here. And so they need to show that they have the technology to do the tracking and to do the calculations based on our criteria. And so we accredit them. And at the moment, this is Carbon Future and Puro are the first two accredited traders. And so we're very happy to see that this thing starts moving. And yeah, as mentioned, they have the very important role to track the carbon sink and then convert that finally into a product or service that they can sell to their customers by creating carbon sinks.
Yeah, maybe just shortly to add that Puro Earth is on track to get accredited, but is not yet finalized. Okay. So.
Yes.
Yeah, thank you, Nicolas, and all that are still here. That was the short run through the EBC carbon sink we established last year, and we see a lot of demand and increased interest. looking forward to develop this further. I mean, this is a first step. We also work on farmer-based carbon sinks in the tropics, and there are a lot of very interesting obstacles to take. It's very nice to have the possibility to engage on this track. Okay, thank you, Harald. Thank you, all of you.
We thank you for this comprehensive overview of the carbon sinks, and I would really like to have another webinar on the C-Sink. That would be something very valuable, and I think there's a lot of interest in it, as it has also already been stated here. We have some questions here. I would like to ask something before. What for me was somehow missing is we were seeing the pathways to carbon sinks, and there were all the solutions were agronomy based. So there might be some other options, and I'm quite sure this is somehow in preparation, but could you just say a couple of words about maybe material uses from in other ways? How can we also sequester carbon through biochar, or can that be certified also?
Yeah, so the thing is, we have to look to the, let's say, an end of sink scenario. For example, you put biochar as carbon black into tires. So as long as the tire rolls, it's a sink, and when the tire got burnt, the sink is gone. So that would mean you have to control the end of sink. And for different materials, you can use average values. For example, for a tire, you know it will be from production to destruction or recycling will be 5 years, then you can account for 5 years. If you use biochar for concrete, then the usual scenario is the concrete will be there for 40 to 50 years and will be recycled then to road construction. That means it's preserved better than in soil, and you could consider it as a long-term carbon sink. If it's in plastic, then so this is about the job of the carbon sink registry. So you register your sink, and then you get into a class of end of sink scenarios. So you have different classes of end of sink. And depending on the class you're in, more or less controlling is necessary. If it's in soil, this is just a mathematical function of degradation. And if it's in different materials, then different degradation rates would have to be applied. So we started with biochar in soil and biochar in concrete because that's easy. And for the next, we head up for providing the backbone to account for it.
Thank you. Yeah, I'm sure for biochar-based plastics, for example, we also have to think about other types of recycling systems to keep materials in a loop or just account differently in terms of ton years or so. So another question, I'll just take one of Marcel Huber before I'm going to Melissa to give the word to her. He has a question about the subtractions of carbon sink value. He says they are going for net zero with their plants, with their production plants, and the company as a whole. And what happens to the sink value? I think it's with respect to what is subtracted from the carbon from the biochar.
Yeah, that's to make a very long discussion. Discussion also with Marcel short. I hope he will not raise the hand to reply to me.
9 minutes.
now we, in fact, what we agreed on is that once a country accounts its forest as carbon neutral, not climate neutral, but as carbon neutral, then we respect this decision, or we do not overrule EU decisions. So if the EU say the forest, this or that forest is considered growing, and then we take the biomass from this forest as climate neutral. So even if from the inner heart of our science we cannot agree on that, we accept it for now. But biochar is not only wood. I think anyway this is only for several more years. Yes, Marcel, you agree that it's still economic to burn wood, and then you can do much better things with wood and paralyze other biomass probably. But that's not on us to decide. So if, for example, Baden-Württemberg or any region that certifies their forest as growing in carbon, then we accept this from EBC as carbon neutral wood.
Thank you. Also, the feedstock was one of my other questions. With respect to the time, we will not wait for Marcel to raise the hand again and ask Melissa maybe to unmute and ask her question.
Hi, everyone. I wish I could have joined earlier, but I was asleep. I'm in Canada. So I did listen to this whole presentation, and I had two really quick questions. First of all, is the EBC involved to develop a Vera methodology with them?
So what kind of methodology?
The Vera.
Oh, the Vera. Yes. No, we hope Vera will come up with something on their own and help us to improve through friendly competition.
Okay, great. Good to know. The other thing is, maybe I missed out on this or I didn't, have enough information, but what is the cost of getting EBC certified for producers?
The current price is €1 per ton of CO2.
Okay. Is that therefore on a continuous, basis?
Yeah, per year. So it's usually a batch is for 1 year, and then we know how much biochar was produced at what carbon sink value, and that's transformed into CO2 potential, which is sold to carbon trader, and we have this information, and then we invoice €1 per ton of CO2, while the value of a ton of biochar-based carbon sink is currently between 50 and €100 per ton. So this is like something like we ask for 1% to establish the system.
All right. Thank you very much. Very interesting.
Welcome, Melissa.
So we have 5 more minutes if we respect our schedule. I see no other hands raised. I have another question in the chat. What would you like from Elisa Cavellin? What would you like to see from a regulatory or legislation perspective? Where do some, and now it's somehow breaking up and I cannot scroll. Do you see it?
Where do you see the most troublesome bottlenecks? I understand you're involved in the first part of the value chain, but maybe you have insight into other C-Sink pathways. I mean, we are from a regular with regard to C-Sink. I mean, we have no real regulation or legislation on that so far. So all this needs to be developed. I think it's critical, as Hans-Peter already said, to really have this, to initiate a separate discussion on the carbon sinks and have that separate from certified emission reductions. I think this is one of the jobs that we need to do. That there's an independent need of creating the carbon sinks, independent of the most radical reduction emissions that we can have, and so that we need to, as much as possible, to avoid the counterbalancing of emissions or avoidable emissions and the carbon sinks, because the carbon sinks have to do two things. In the long run, they need to cover what we cannot avoid with regard to emissions. There will be always emissions that we cannot avoid, but on the other hand, they need to account for the historic emissions and emissions that we cannot reduce as quick as we need to. And so this is why we have to avoid the counterbalancing with avoidable emissions.
Yeah, we also, I mean, we see the carbon register that Nicholas talked about. So this is like a central register where all the carbon sinks are firmed, like for housing or for land properties. And we see this in the hand of the nations. And we also see the nations to have national objectives for carbon sinks. Like, for example, Germany would say we will need until 2035, we need whatever, a megaton of carbon sinks. And then this can be paid from CO2 emission taxes, for example. But we do not see this as a private endeavor of like-minded people. I mean, this is really about the global climate, and it has to be done by the nations. But we try to bring it one step forward and to test such systems, to develop such systems, so that when the governments are ready to understand the urgency, that they can already use systems that work and do not need to start from scratch. So that's why we do it.
Yeah,
I think therefore
there's definitely limits to what we can do as a private foundation. This is a very important aspect.
Mm-hmm. Yep. Okay, I think it's the EBC Sink certification is very valuable in this regard. Also, with regards to communication and teaching or schooling, showing an option, a concrete option where you have tons of CO2 equivalents sequestered, because biochar is still sometimes not considered on the same levels or so of security as direct air capture or BECCS solutions, because it somehow falls into this category of nature-based solutions, and it's certainly a hybrid, because biomass is nature-based, but it's a technological option. So I think this consideration is very important also. Well, we have reached 15 o'clock, 3 p.m. Again, perfect timing. We have no more urgent questions. I'd like to thank you a lot for this very interesting session. It was, I think it was very comprehensive also, and some of our participants might just have a look on the recordings to repass and recap all the informations you have provided. I'm really looking forward to this next webinar, as I see it as a proposition to have another one on EBC Sink. thank you all a lot. Also, Heike Renner, I think you're still there, for your input. Yes. And everybody for participating. Have a nice evening or night or morning or day, because I see we have participants from all over the globe. And see you next time.
Thank you so much. Bye-bye.
Yeah, thanks for hosting us.
Thank
Goodbye.
you, everybody. Bye.
Bye-bye. Bye.
Thank you very much. Bye.
Bye.